Assalamualaikum and good afternoon. Today we will discuss about turbo machinery. And then for turbo machinery, there are two types actually, two machine that we need to be discussed here. One is pump and one is turbine. So for the first chapter here, so we would like to discuss, I would like to share with you something about pump, and we focus on centrifugal pump here. So for general information, turbo machine are the commonly employed device that either supply or extract energy from a flowing fluid by means of rotating propeller or vanes. So here in turbo machinery, we have two major device. One is pump and one is turbine. So the difference between pump and turbine is pump adds energy to a system with the result that the pressure is increased. It also causes flow to occur or it increases the rate of flow. Okay, so the major difference between pump and turbine is pump is a device which give you more energy. It will add energy in your system. However, for a turbine here, so turbine will extract energy from a system and convert it to some other useful form. So typically to electric power. So hydroturbine is a machine that generates power from high pressure water. Relatively large conduit or tunnels deliver fluid to closed turbine in order to generate power. So another example for turbine is steam turbine and air turbine. Okay, so here please remember the Bernoulli equation, because I thought you already remember the Bernoulli equation in your fluid mechanics 1. So normally Bernoulli equation can be written as P1 over rho G plus V1 square over 2G plus Z1. So it must equal to the total energy at output. So total energy at output is P2 over rho G plus V2 square over 2G and plus Z2. Okay, so because pump is adding energy to your system, so it must be added in the inlet. So we will write as head of pump. I think the form for this one is already taught in fluid mechanics 1. So, and then turbine is something that extract energy. So means that we need to add the idea of turbine in the output. So we put head of turbine at the output here. So this is another reason why we call pump here is something that add energy to the system, and turbine is something that extract energy from the system. So another thing, another simple example that you could will give you idea about this is if you have an aquarium at in your house. So if you have a pump, so you will find that if you plug in the pump will rotate whether the water exists or not. So means that you could run a pump without any fluid through it. So means that pump could run by itself. So means that pump already have its own energy. However, for turbine, so the simple turbine is actually the wind turbine. So we have a water turbine. So means that if the wind or the water not flow through the blade, so the turbine will not rotate. So means that turbine is something that extract energy from the system. So this is the basic idea about the turbo machinery. And then in this topic, we will focus on what happened inside a pump, because we already know the how to solve problem using pump and turbine in fluid mechanics 1. That's why you already know to write this Bernoulli equation. And in fluid mechanics 1, we already know how to calculate the head of a pump, you already know the meaning of manometric head and so on and so forth. So in this topic, we will only focus what actually happened inside a pump, and see how it's how the losses inside the pump and so on and so forth. So means that in this topic, we are focusing only what happened inside a pump. Okay, so this is the classification of pump. But before that, okay, so maybe we could add here if we want to add about the turbo machine. Okay, so turbo machine means that we use machine here, we use machine to add or extract something. So turbo mean you give a massive changes of energy in the system. So the massive changes mean it can be plus, it can be negative, it can be minus. So if plus means you are talking about pump, because pump will give you massive energy in the system. But if you are talking about the minus side, mean it's about the turbine, because it extract energy from the system. So we have a turbo machine here, so it could divide into pump and it could divide into turbine. Okay, so the detail about turbine here will be discussed in the next chapter. So in pumps here, so we have two types of pump. So one, we call it as a rotodynamic or dynamic pump. And another type of pump is called a positive displacement pump. Okay, what is the difference between two types of pump? So for dynamic pump, okay, it uses the idea of kinetic energy. So means that first we need to rotate the blade. So and then when blade rotate at certain speed, so means that blade has kinetic energy. And then we let the fluid flow through the blade. So mean now the fluid touch the blade. So now at that moment, the kinetic energy will be transferred from blade to the liquid. So that transfer means now the liquid has higher energy. So because liquid has more energy, so liquid could move from lower level to the upper level, or because it has more energy, fluid could move in high velocity. Okay, that is the idea of dynamic. So another type of pump is called positive displacement. So what is the meaning of positive displacement? So it's reflect the idea of volume. So means that water being transferred from one place to another by its volume. So the simple example of positive displacement pump is shrink or pichagari. So you suck water and then you transfer it to another. So for example, everybody here is already taken your vaccine. So nurse will use a syringe, okay, to pull liquid into the syringe, and then it's transferred from the vaccine bottle to your hand by syringe. Okay, that is the idea of transferring fluid. So it's not using the idea of kinetic energy, but it used the idea of transferring the volume. So we will discuss about this, not in this chapter, but if you have interest in positive displacement pump, so in your fourth year syllabus, there is one option subject called system pipe and turbo machinery. So in that topics, in that course, so we will discuss about the positive displacement pump. Okay, so in positive, okay, so we go back to our syllabus here about the dynamic, rotodynamic here. So in rotodynamic, so actually there is one common type of pump which is called the centrifugal. So the centrifugal, why it's called centrifugal? Because it used the idea of centrifuge force. Centrifuge force. So the idea is simple. For example, if you have a bucket here, so you fill it with half of water, and then let's say you hang it with a certain system, and then you rotate it at certain speed. So after at certain speed, you will find that the water level will become like this. Okay, why the water level will shape like this? Because when you rotate this bucket at certain speeds, so there is a force called centrifuge force that that push this water to the wall here. So the centrifugal pump here is using the idea of centrifuge force. That's why we call it as centrifugal pump. Okay, that is the idea of centrifugal pump. So I hope you could read from textbook and also read from internet and so on about the centrifugal pump, because it is most common pump used in this world. However, not all application can be used centrifugal pump. Okay, for example, the advantage of centrifugal pump is it can be run in high frequency, in high speed. Okay, but the disadvantage of centrifugal pump is it cannot be used for transferring viscous fluid. So viscous fluid means fluid that are very thick, fluid that cannot flow. For example, the simple one, if you are managing a food factory, for example, you are now transferring mayonnaise from one section to another section. You cannot use centrifugal pump because mayonnaise is not 100% fluid. It is actually a mixture of a lot of ingredients, and we found that the viscosity of mayonnaise is very thick, it's very high, because mayonnaise cannot be flow, it cannot flow. So if you have a thicker fluid, means or viscous fluid, you cannot use centrifugal pump. On that time, you need to use another type of pump which called positive displacement. So please read something about the difference between centrifugal pump and positive displacement from your textbook. Okay, however, centrifugal pump is still the most common pump because it is simple and it has the price is also lower compared to another type of pump. Okay, so and then for dynamic pump, okay, for centrifugal pump, we have three types. One is called the axial, and one is called the radial, and the other one is the mixed one. So normally in our syllabus, we are focusing on the radial type of centrifugal pump. So what is the difference of these types? Okay, so the basic idea, okay, about axial, radial, and mixed is, so the axial here is if the input flow and the output flow is on the same direction. So means that input flow here is horizontal, then the output flow here is also horizontal. Now we call this as the axial pump. So however, if the input flow here is horizontal, but suddenly when you want to transfer the energy from the blade to the fluid, so you need to change the direction into vertical direction like this. So we call it as a radial pump. So it doesn't count on this side because this is just the channel of the output pipe. Okay, we will see that later on in next chapter. Okay, because the basic idea is if you have a long pipe here and then you have a long blade and it's rotate like this, so the inlet flow and the outlet flow here is the same, so it is called an axial pump. Okay, so normally for the centrifugal pump, so it will flow like this. So inlet flow will flow horizontally, but the output flow will flow vertically like this. So we will see the detail about the flow here in the next slide. Okay, but the idea is if the inlet and outlet flow is remain the same, so it's called the axial pump. But if the outlet flow is changed 90 degree, so we call it as a radial pump. So this is the two common basic pump. However, nowadays when people do more research on centrifugal pump, so they will find that sometimes it is good for us to have the mix combination like this. So the mix here is we have the outlet direction here at certain gradient, at certain angle. Okay, so this is another example for piston pump or reciprocating pump. So the idea is simple. As I said, it is we transfer fluid in terms of its volume. So you could imagine here, so we have a piston here. So when the piston goes down, so and then when we'll pull it up, so it suck water here, and then when it press it down, so the water will flow out. So you could see here there is a movement, but there are no kinetic energy being transferred from piston to fluid. So means that the movement of the piston is actually not the main reason to transfer water from point A to point B. So that is the difference between positive displacement pump and dynamic pump. Okay, so again, this is the idea of Bernoulli equation when we use pump. So we put head of pump in the inlet here because it will increase the total amount of energy in the system. So and then we will put turbine here at the outlet of the system because turbine also will extract energy from the inlet. So we put it at the outlet here. Then please make some revision about major losses and minor losses, because in this topic sometimes you need to calculate your problems by adding the major and minor losses. Okay, please check, please do revision on minor and major losses.